Okay. Today we will study the paper published in Marine Pollution Bulletin last year or this year, titled Vessel-Based Photographic Assessment of Beach Litter in Remote Coast, a wide-scale application in Seronikos Gulf of Greece. This paper was written by Greek researchers from some NGOs and university. Why we picked this paper is OSEAN is interesting in rapid assessment of beach litter, especially efficient monitoring tool for monitor distribution of beach litter in a wide area of coast. I will show you our paper about this method. We published this paper last year in Marine Pollution Bulletin titled Rapid Assessment of Marine Debris in Coastal Areas Using a Visual Scoring Indicator. So you can understand we are trying to use a visual scoring indicator for surveying marine debris for rapid assessment method. In this research, we used this kind of indicator depicting the level of marine debris in a designated area, and we provided some description and some photos from our Japanese friend, and our surveyors used this indicator for assessing the amount of marine debris in a beach, and we've conducted a nationwide survey and produced this kind of result showing the spatial distribution of marine debris in Korean coast in 4 survey season in Korea. With this picture, we could find out some hotspot areas in Korean coast. And we find out that in a very small area of coast, most of debris are accumulated. So if we can identify this hotspot area, we can plan the systematic beach cleanup in these areas, and it would be an efficient way of managing marine debris in beaches. And we estimated the total standing stock of marine debris in Korea with this method, and we also found out the potential source of marine debris and the type of marine debris in our coast. So we want to develop this rapid assessment tool for marine debris survey and monitoring. This kind of approach for using vessel for remote area would be very helpful for us to develop more efficient, accurate rapid assessment tools. So at this time, we will check this contents of this paper. I will read the abstract first. The abundance of marine debris was quantified for a total of 62 inaccessible beaches in the western Seronikos Gulf, Greece. High-resolution images were obtained through vessel-based photography survey, merged into seamless photo mosaic, and manually processed to quantify beach litter abundance. A sample of 4 selected beaches were subjected to detailed photography, followed by beach macro litter in situ sampling. surveys over a period of 1 year to calibrate and validate the proposed method. Regression analysis between photographic and in-situ data showed a significant correlation, hence providing a highly accurate regression model to assess the real number of beach litter stranded on the list of investigated beaches, exhibiting clear correlation to the hydrodynamic status of the area and provide an indication of a main litter source. The proposed method is an easily applicable and useful tool for fast and low-cost macro litter monitoring in extended remote coastline when only photographic data are available. So I think you can easily understand the main contents of this paper. We will check the figure and table first. Figure 1 showing the survey area in Greece, and figure B showing the flow trajectories in these areas. So you can see the surface floors are showing kind of anti-clockwise, cyclonic circulation in these areas. And the figure A showing, figure 1A showing the survey areas, including the observatories of 4 beaches and photographed beaches over 60 spots around these basins. Let's go to figure table 1. Table 1 is explanation about the 4 observatories. You can see 4 observatory beaches and another 58 beaches which the photograph survey was conducted. We can understand that almost all the site observatory in situ and photography survey was conducted on the same day, except for one occasion in PGC. And survey was conducted from August 2017 to July 2018. And let's go to next figure. Figure 2 showing the results from photography survey. You can understand the boat went through this way, and they took the photos from A to B on the coast, and they generated this kind of photo mosaic to showing the marine debris on these beaches, and they found out this kind of marine debris and pointed with a black dot on marine debris, and you can see the zoomed photos of the debris like beverage bottle, cap lid, or disposable cups and other debris in photo mosaic. Let's go to figure 3, showing the results from 4 observatories showing the material shares. We can understand that plastic polymer materials dominant in situ survey and also remote photography survey. And we can find out that processed wood was somewhat higher than in situ result. And but they excluded these kind of small or unidentifiable materials like polystyrene piece or plastic pieces. But from the in situ sampling, these type of marine debris was dominant. But in remote photography, they could not find out these small pieces of marine debris compared to in situ survey. And we can understand that the potential source of marine debris from the result. The single-use plastic was dominant in situ or remote photography. And with the figure C, we can understand the top 10 of single-use plastic on 4 observatory beaches. The cover and packaging was dominant in situ survey, but from remote photography, cover and packaging was not that well detected compared to in situ survey. But the order of the top 10 single-use plastic items are similar between two survey methods. And figure 4 is showing the temporal variation in beach litter in 4 observatory beaches. So we can understand that from the fall to winter, the beach debris was increasing. So the winter of 2018 was a kind of a peak and showing decreasing trend after that. With figure 5, we can understand that in 4 observatory beaches, the in situ, the abundance of marine debris from in situ and remote photography is showing quite similar patterns in different survey season. So we can understand, we can generate some kind of regression model with this result. And figure 6, we can find that result from regression model. Figure A is showing linear regression model, and figure B is showing split regression model. That in the text, I found out that they found out that with a number of 60 marine debris, they found out that under 60, the linear model was quite good, but in case of over 60 marine debris, they should apply this kind of log transform, log equation for the beaches of the beaches have over 60 count of marine debris, and they are showing the C is a linear regression model, and D is a split regression model. So the split regression model showed a much higher R-square result. So we can understand that we should apply split regression model to predict the number of debris with a photograph result. Next, figure 7, showing also the material share and potential source and top 10 debris item among single-use plastics from all 58 beaches where the remote photography surveys were conducted. Table 2 showing the total number of beach litter items per 100 meters for observatory beaches, and table 3 showing a regression analysis results from these beaches in 4 surveys. So I've already told you that spread regression model was more accurate than linear regression model. So you can see that the error ratio is smaller in spread regression model. Okay, I think, and then they produce this kind of spatial distribution map of these basin areas. And with this picture, you can find out hotspot areas in this Kira Island or other eastern coast of the basin, western basin of the coast. This result can be matched with this kind of a flow trajectory map. So these anticyclonic circulation would end up with this kind of accumulation of marine debris in these beaches. And also some kind of socio-economic factors like a big city in this area or port in these areas are also affected this result. We will check the contents in the text. Okay, that's all the figures and tables. Let's get back to the introduction. But do you have any comment or question about the figure and tables? Okay, I will quickly check the main contents of the text. First, in the introduction, they start with the distribution of marine litter in global ocean. We can find out the marine litter in shoreline or water surface or even seabed. These marine debris are generated from diverse human activities, and they drift to various marine environmental compartments. And especially for beach litter are affecting marine ecosystem and also socio-economic implication on human society. The marine debris can be a factor in transportation of non-native species, and we've already heard about many times about the nano and micro-sized particles, which can release toxic chemicals to environment. So the evaluation of abundance of marine debris is a complex assignment because the beach litter can travel over long distance. So it is very difficult to predict the transportation or distribution of beach litter. And they are showing non-linear pattern of accumulation. So because beaches are act sometimes as a receptor, but sometimes it acts as a secondary source of beach litter because some debris can be washed off from beaches to the sea. So we need some kind of a systemized shoreline monitoring program, especially in remote and aerial monitoring method could be applied for a wide area of beaches. But in this kind of remote or aerial monitoring method, like aircraft, balloons, or aerial vehicles, or webcam, need some considerable operation cost or some level of technical expertise and ground variation surveys. So we need to develop some fast and wide scale and low cost beach macro-litter assessment tool. So in this paper, they are suggesting some kind of a novel method with a photography and statistical analysis of a manually detected beach litter count. They suggest a simple split regression model was adequate to predict the real number of stranded beach litter. So the aim of this paper is to provide a simple monitoring guideline with a small vessel and digital camera and free software for analysis. It could be it is in line with a MSFD guideline or UNEP guideline for marine debris monitoring, and also the GESAMP guideline for marine debris monitoring, especially in area of and so the result, the method can be used in area of most concern and to organize a targeted cleanup in the concerned area. Okay, this is introduction. Do you have any comment or question? No? Okay, I will go to method. Method is somewhat long, but I will try to as fast as I can explain it. First, the study area was Gulf of Saronic Cross is a kind of partially enclosed basin. It has some kind of socio-anthroponic pressure from the kind of big city in Aden or Pierce City Port, which can generate some amount of debris. It can be, it can have some kind of two parts. The eastern part is a flat basin, and western part has some deep area. And the oceanographic settings of this basin could be said that it has oceanographic circulation and seasonal flows. So in winter time, it has a eastward flow, and summertime it has a westward circulation, and it has a close anticyclonic loop in the northern part of the west sub-basin throughout the year. And they have a surface circulation map result from Copernicus model from the previous research. And their strategy for sampling is on 62 inaccessible beaches among them, the 6 beaches located on Kira Island. These areas are not subjected to human activities, and they selected 4 beaches as observatory. And they conducted vessel-based photography, total beach cleanups, and sampling microliter in 4 seasons in a year. We've already checked the contents from table 1. In observatory, the criteria for selecting observatory was beach morphology and sedimentological characteristics, and orientation of the beach directions, and they want to consider influence of diverse source of beach litter, and they want to have a sufficient geographical coverage to ensure the representativeness of the sample in the area. They explain about the 4 observatory beaches characteristics. And next part, they are explaining about the vessel-based photographic recording. They use 9-meter long plastic board and high-resolution photography taken by Nikon digital camera and lens. The distance of photographic survey was 10 to 20 meters. They want to have an optimal weather condition, and some operational treatment was done to the camera setting. And then they took the beach cleanup in their observatory beaches and recorded debris according to EU MSFD guidance on monitoring of marine litter. They used 3 skilled personnel. They found that the 3 skilled personnel was the adequate to conduct photography and in situ macro debris sampling, and 2 are enough for remote photography survey. For data preparation and analysis, they register this data in a kind of a database format with the beach, date, period, material, item, and uses. And then they generated a panorama photo mosaic with a Fusion open source software. They use 30 to 35 frames per 100 meter beach length to generate the mosaic photo. And then they put the photos to the QGIS program, and they generate the result about written material category and coordinate the location of each result or the beaches. And then they use Pearson correlation and regression analysis for predicting the real number of beach debris using photograph result. They excluded the small pieces of plastic and expanded polystyrene. I think this is somewhat tricky or problematic part of this result, because in terms of number, these small pieces are affecting the major result of the survey, but they excluded this result. So we can understand that the result of these results has a very underestimated number, with excluding this huge number of small pieces of plastics. And then they generated some kind of 100-meter length item result. Then they generated some kind of distribution map, and finally conducted a trend surface analysis using the results, their result, and the circulation of Sereniko's curve. Okay, that was the method of this research. Any comment or question about the method part? Okay, I will go to result, but I think we don't have much time, and I think we've already checked the result from the figures and tables. So I will quickly check the main result. I think we've already did share or proportion of the material and items, and we've already seen the temporal trend, seasonal pattern from the figure, and with the figure 5 we can understand that the in situ survey and remote photography has quite a similar but very good correlation. And then they applied the regression model. With the linear regression model, it was good, but they found out the noticeable change with a number of 60 items. And they applied a split regression model from 0 to 60 and 60 and more. And they produced more well-fitted regression model with a split model. And then they estimated number of beach litter from the photography result. So they found out it was about 3.5 times higher than the photography result. And then they produced the composition of the predicted beach litter. Now I go to discussion, and they are saying that with this method, they found out significant relationship between in situ and vessel-based photography result. So this kind of a method has some strengths in terms of quality photographic documentation, spatial coverage, processing time, and operation cost. While this method can be done by non-experts. And they are talking about the Amare project from EU. It is a test of drone technology for assessing marine debris in wide area of beaches. But for aerial photography monitoring, it has some restriction like flight restriction, and it needs some kind of higher operation cost because we have to use some drone or airplane with this monitoring tool. Even quadcopter, kind of drone, and is has some limitation like short flight time. But in some areas we can use as an auxiliary of the rapid assessment with the drone, like the area with some limitation with boat accessibility. Or webcam has some kind of limitation like setup complexity or maintenance, and also operational cost. And also this kind of monitoring method using some tools, some equipment, expensive equipment like drone, airplane, or webcam has a risk of equipment lost. And some method has a limitation in image processing. And size estimation restriction in case of low image resolution. Okay. And they are talking about the limitation of this kind of camera technology, like camera specification restriction, natural lighting, and beach morphology can affect the result or quality of the result. And we have to consider some heterogeneity of the image, and we should have some kind of consistency in our method or in our survey. And we should consider some human error in this method, and the vegetation can affect the result of the quality of the result. And also we should notice that this result can be applied in very recognizable shape of a marine litter. As we already saw the small pieces or white styrofoam, white expanded polystyrene pieces cannot be detected with this remote photography method. And they found some fishing and maritime related plastics was second most significant marine litter item in these areas. The synthetic rope are in top 10 item. And some kind of big marine debris like fish farming platforms or cages were found in this way. So these kind of fishing related items are important source of marine debris in these areas. And they talk about packaging or the drink bottle in this area. And then they talk about relationship between marine debris distribution and the surface circulation of this basin. Okay, next, the conclusion. With the conclusion, they say that vessel-based remote photography showed a very good regression analysis result. So we can use it to predict the number of marine debris on the beaches in a very wide area. Like for this survey, 6.5 kilometer of remote coastline was covered in a couple of days. With a small number of surveyors, and they need 3 weeks of data processing time. And they find out plastic polymer was the most abundant beach litter item, and single-use plastics are contributing the major source of plastic litter, but marine debris on the beaches, and they are suggesting that this method can be matched with the EU or UN guideline for beach litter monitoring, and could be used for developing plastic strategy in EU or other areas. So they suggest the future investigation with meteorological and sea current data analysis and repeatation of this kind of method to enhance the generation of a spatio-temporal model for beach litter concentration regarding same areas like these Greek basins. Okay, I think we can go to supplementary information. In supplementary material, they presenting the result, kind of raw data from their survey, and some kind of photos. Okay, that's the main contents of the paper. Do you have any comment or question? Okay. Rebecca or Yanning, do you have any comment or question?
No questions from me, no.
Thank you. I don't have questions at all.
Okay. I think we have a Korean audience here. So, do you have any question in Korean? Jolene left some message for us. Yeah, she introduced Rebecca. Okay. Okay. This is not the question about the paper. Okay. If you don't have a question or comment, I think I will ask some question for you. I can't find out it. I think Yanning has some experience with rapid assessment with a visual scoring method in Taiwan. She already produced some kind of marine debris distribution map of Taiwan and are trying to apply it for cleanup in Taiwan area. I want to hear about the proceed about that kind of approach. Yening?
Yes.
Do you have
Hi
any
everyone.
progress in that project?
Yes. So we finished the rapid assessment last July, and last April, and we published a report on the result of rapid assessment, and we present that the top 13 most polluted coast areas in Taiwan. So after that, the government they hold several emergency meetings to handle this issue, and the cabinet took this issue seriously. So the cabinet asked EPA, the Environmental Protection Administration, to become the coordinator, to coordinate different government sectors to do the cleanup and make strategy for future cleanup in the following year. So by the end of 2019, I think the government sectors who are responsible for these top 13 most dirtiest coastlines, they already make budget for cleanup for 2020 and the following 3 years. And this year we will continue doing the rapid assessment for Taiwan government, and not only the main island of Taiwan, but also the remote islands. So we will keep monitoring the polluted level of marine debris, and it will become a kind of a criteria for the government to evaluate how the efficiency they do the cleanup. So that's the progress now, and we plan to do the rapid assessment in late March or the first week of April. That's our plan for this year.
Yeah, very good.
Sounds good.
And one thing I want to add is with our visual scoring method, it is very difficult to apply it to inaccessible beaches, because in
Yes.
visual scoring method we have to land on
Yes.
the island, but in some cases we don't have access points for the landing. So this kind of photography method would be kind of auxiliary for our visual scoring method. So I think we can apply this kind of photographic technology combining with our visual scoring method to test the applicability of our visual scoring method for inaccessible beaches.
Yeah, I think this paper is quite interesting, and since we have some beaches that we cannot easily access to it, and also we have lots of remote islands. So I think, yeah, maybe we can try the method in this paper and like try it in Taiwan or in Korea's coast.
Okay, we will try it. So,
oh, really?
Our survey design, and we can do it together with a
Yeah, sure.
Okay.
Okay.
If you don't have any other comments, I think we can wrap up this seminar. Okay.
Yeah, okay.
Thank you very much.
Thank you, Dr. Lee.
And we